John has certain number of chocolates. If he decides to distribute these between 3 children, then he is left with 2. And if he decides to distribute these between 11 children, then he is left with 3. What is the maximum number of chocolate he has, given that it is less than 500? Now the number of chocolates that he has got, he is wanting to divide it among 3 children. He is left with a remainder of 2. That means what? The number n should be of the format 3k1 plus of 2. Now, the same number of chocolates, if he wants to divide between 11 of them, then he is getting a remainder of 3. Then the number n, the same number n, must be of the format what? 11k2 plus of 3. Correct? We are referring to the same number, and hence I can simply equate 3k1 plus 2 should be equals to 11k2 plus of 3. Now go further. 3k1 will turn out to be what? 11k2 plus of 1. If you look at k1, it is going to be 11k2 plus of 1 divided by 3. Now understand, k1 and k2, both the values have to be integers. Correct? Now let's break this further. K1 will turn out to be equals to what? 9k1, 9k2 plus 2k2 plus 1 divided by 3. Why am I breaking it as 9k2? Because 9k2 will definitely be divisible by 3 irrespective of the values of k2. So that lowers the value of the expression that I will have to iterate. So this is the expression that I'll have to iterate to get an integer, right? So k1 will become what? 3k2 plus 2k2 plus 1 divided by 3. So what should be the value of k2 so that this gives me an integer? Of course, then k2 should turn out to be equals to 1, because if k2 turns out to be equals to 1, the numerator present over here will turn out to be equals to 3, and 3 by 3 will give me what? 1. So if k2 turns out to be equals to 1, then I'll get 2 times of 1 plus of 1 divided by a 3, and k2 over here should also be 1. So k1 should effectively turn out to be what? 3 into 1 plus 1, which turns out to be what? K1 is 4. Right? So we have our first number. Either you take k2 as 1 and put it over here, or you take k1 as 4 and put it over here. The number n turns out to be equals to 14. So this is my first number. The lowest possible number of chocolates that I should have, this person should have, is 14. Correct? Now, what is the series of numbers which will actually satisfy this particular set of conditions is what we need to understand. Now, 14 is the first number that I'm getting, and this is where the question is getting a bit more tricky. Now pay a very close attention. It says 14 is the number of chocolates plus 3 and 11. The LCM is what? 33. So if I look at the number of chocolates in the series 14 plus 33k, this will always give me the condition which is given on the question. Look at this. 33k will be divisible by 3, will also be divisible by 11 irrespective of the values of k. So the remainders are always going to come from what? 14, and 14 will give me the same remainders always. So my series of numbers will be this. Now they are asking me to maximize the number of chocolates, and it is given that it is lesser than 500. So what number is lesser than 500 and giving me this kind of a value, right? So you will start iterating the values of k over here. Now I understand 33 into 3 will give me 99, 99 plus 14 will cross 100, right? I wanted to go close to 500. So 33 into 3 will give me closer to 100. Multiply that by 5, it will give me closer to a 500, right? So if I try to test this particular value, I'm going to get a 99 into 5 plus a 14, right? This is going to give me 495 plus of 495 plus of 14. Which is of course greater than 500. So I'll have to go one step lower than this particular piece. Okay, this particular piece was what? 15th multiple of 33. So I'll now take 14th multiple of 33. So 14 plus 14 times of 33. So if I look at this, this turns out to be effectively 14 times of 34. And if you look at the option choices, you will realize this number will come down to 476, which matches with the option A. So option A will be the correct answer for this question.